Our next speaker will be someone that's known to all of you. Brian Whedon, who is the Executive Director of CONFERS, has got the next highlight panel. Again, include your questions if you can throughout the day. Remember, use the Q&A feature that is available on your screen. So, Brian.
Thank you very much, Harley. And thank you again to Dr. Denzing for joining us this morning as our second keynote. So yes, hello, morning. As discussed yesterday, while the satellite servicing industry has made really big steps in proving out some of the technology and capabilities, we still have a lot of work to be done on proving out the business model and integrating what satellite servicing can offer into the overall space economy and reach some of those lofty goals that we all hope we can reach someday. So to that end, this next panel is going to try and shed some light on that topic. We're going to be discussing not only how satellite servicing can contribute to the broader space economy, but also what the steps and challenges and actions that we can do that need to be addressed in order to get to that vision of a vibrant, robust space economy where satellite servicing is not only a sustainable business, but is contributing to that. Joining me today to talk these issues, a panel of experts from various backgrounds, each with a lot of experience in different parts of the space industry and trying to solve some of these challenges. So we first have Ms. Carrie Mullins. He's the analytic lead for Bryce Technologies Space Consulting Practice, and she has more than 20 years of experience analyzing and forecasting advanced technologies and systems for NASA, the military, and commercial space industry. We also have Captain Dalton Hayes, the government lead for this Catalyst Accelerator at the Air Force Research Laboratory, where he is responsible for a government-funded dual-use space technology startup accelerator that is focused on delivering emerging technology to warfighters and expanding the defense industrial base. And related to satellite servicing, earlier this year, they had a cohort of companies specifically on satellite servicing. We also have Mr. Rick Tomlinson. He's a longtime space visionary, co-founder of many space startups and organizations, including most recently the Space Fund and the Earthlight Foundation. And finally, Dr. Gordon Rosler, who has had a long career in both government and industry, working on the application of robotic technologies to space missions, including the SUMO, FRIEND, and RSGS programs when he was at DARPA, and he's now a consultant with Robots in Space, LLC. Welcome to all of you. I've asked each of the panelists to provide some open remarks that set the stage, and then following those remarks, we'll be having a group discussion of those issues. During that discussion, we do welcome audience questions. As usual, please submit them into the Q&A box, and I'll try and get to as many of them as possible. So, Carrie, I think I'll turn it over to you to lead us off with your opening remarks.
Thank you, Brian. To the rest of the panel, I'm really excited to be here. If we just want to go, I only have like 2 charts just to kind of help this stage setting. So if we can go to my first chart, maybe, there we go. So I want to look at the overall, the OCM ecosystem, and really satellite servicing is such a big piece of this. But the first question before I kind of jump into how does it fit into the global space economy is to look at this. How are we going to define the servicing markets? When we're at Bryce and we're trying to look at these new markets, right? We really only have 1 or 2 operational players right now in this ecosystem. A lot of the work is still being done at the technology and capability level. So, you know, we need to figure out how these pieces fit together to form our markets, which are then informed by the larger space economy. So we start by looking at these technologies. You know, these are things like your proximity operations, all of your autonomous systems, your grappling capabilities, the things that you need to do to be able to conduct these activities in space. And so at Bryce and on some work with NASA that Gordon supported us on as well, we developed an activity breakdown structure to really be able to break down the pieces of things that happen in servicing. So whether it's repositioning a client, inspecting a client, repairing, really trying to pull out those separate pieces that when you cluster different activities together, that gets you to certain markets, right? And so These are the things, that are really driving the design of these systems, to get to these activities in these markets. And then what we'll see as we go into the future, right, is that the technologies and capabilities, they start to support multiple markets. We'll start to see things coming together and even broadening more. So as an example, in these servicing markets, one of the things we'll start to see is we've got active debris removal right now, some demonstrations happening, and say the life extension missions happening. But a lot of the things they need to do and the capabilities they need are similar. So we'll be able to see some potential interchangeable capabilities that would allow these providers to enter into the different markets. And you can particularly see this with Astroscale and Northrop Grumman, as they have long range plans to enter different portions of these markets. So if we could go to chart 2. I do want to be conscious of the time as well. This is our look at the overall global space economy. And really within this economy, satellite servicing and on-orbit servicing addresses 3 broad markets. The biggest one, of course, being the satellite value chain. And then it also plays a role in human exploration and then R&D and science. I'm going to start with this satellite value chain. And what you can see on the chart here, on this pinwheel chart, is satellite services are a huge part of our global space economy. And so this is an activity, a market that will really support that market as part of it. And so when we look at the satellite value chain, this is definitely the biggest market. We are looking at a number of kind of sub-markets that have a very high likelihood of occurring. And while it's maybe only in the tens of millions of dollars in this near term, while we're demoing and getting initial customers, as we start looking in that 10 to 15 years, these markets might grow possibly even to the hundreds of millions of dollars. And we're looking at things like markets like extending mission life, active debris removal, moving satellites. So this is some of your space tugs that we're starting to see, and even a small inspection market. But these have a fairly high likelihood and a potential for a lot of money, a large market. So the largest market that we're looking at is servicing high value, large, primarily GEO satellites. These assets in GEO are worth a lot of money. Keeping them on orbit allows them to generate revenue for longer periods. And we're starting to see this with the Intelsat demos and the MEV. On the LEO side, right, we're seeing these gigantic constellations, but they're perhaps maybe a little less likely to need servicing, as they're designed to work without a full complement of their satellites. The low cost may make it preferable to replace them rather than service them. But on the other end, and the interesting thing here is when we look at from the debris removal side, we've seen 2 of the mega constellations, OneWeb and Telesat, have confirmed that they're planning to equip their satellites with servicing features so the satellites can be removed by an ADR vehicle. And one of the really interesting things here is that's not really being driven at this point by regulatory concerns, but by their business and economic decisions, right? So they want to make sure that they can keep things clean to ensure that it's to prevent endangerment from other spacecraft. So seeing them make that business decision is really interesting from the LEO market perspective. So then the other thing is, while the high value satellites are most likely to be serviced, we do see that individual companies are really thinking about why they would or would not want to be serviced. So some of the things that they're looking at is, one, they're not currently designed to be serviced. And as we get new, in the future, we'll see this progression potentially of satellites adding these features so that they can be more easily serviced. But right now it's kind of expensive and it's fairly risky. And the GEO operators tend to be a more risk-averse group. But we are seeing the demos, and I think as we continue to see more demos, we'll see more and more GEO satellites that are willing to be serviced. So then as we look at the other 2 markets, human exploration, this is really the most promising markets here are going to be government markets for exploration. Perhaps it's refueling either surface landers or in-space vehicles as they start to come on, and that's really going to be further out in the time frame. And then the current market is really more of just demonstration missions coming from the government for different kinds of surface servicing or other OSAM activities. And then in the science and R&D, these are potentially less likely markets. Mostly we're looking here again at potentially like large government telescopes that would require servicing. So this is a little bit tougher than, say, the satellite or the human exploration value chain. So there's a little, it's a less likely market, but it's a potential one as well. So to kind of close out the overall look, I just wanted to note that I think one of the most interesting aspects of the satellite servicing market is that it has been largely commercially driven. Not that we've certainly seen government work in here. We've seen RSGS, we've got NASA with their OSAM-1 and OSAM-2 missions, but there's a lot of commercial interest, and I know our other speakers are going to speak to that some more today. Even before Northrop Grumman has just received its RSGS contract, but they were already providing commercial activities to commercial customers. So I think this is a fairly exciting market as we see it being led by commercial companies. That's what I have for now. Thank you.
Great. Thank you very much, Carrie. Now, I think, Dalton, are you up next, I believe?
Yeah, I can go ahead.
Great.
Hi, everyone. So I am Captain DJ Hayes from Air Force Research Laboratory. Currently, I'm a Defense Ventures Fellow. But in my normal day job, I manage the Catalyst Accelerator program on behalf of the Space Vehicles Directorate. And I get the question a lot, what is an accelerator program and why is AFRL doing that? It's not your traditional R&D work that the labs normally conducts. And so our focus is to build an entrepreneurial base, specifically for the space ecosystem. And we do that by bringing startups into our 3 accelerator programs and have them become market focused, but mission aware. And at the end of the day, the best scenario is when we can take a startup that has a technology that applies in the commercial market, and with only a few small tweaks, we can modify that for military use and actually give that to warfighters. And so that's the scenario that we're really pursuing with the accelerator program. And the funny thing about this program is it's fairly new. We started in 2017, and we've run 8 cohorts of 8 companies through this program. And so we're like a startup, and we're still executing this build, measure, learn process every time we do an accelerator, and how we can improve how we work with industry. And so one of the main things that we're able to do is we're able to take companies and break down these barriers, especially the barriers of not having a .mil email address, and be able to have these companies sit down with program managers and warfighters and truly understand their needs, because asking questions through the DSIP portal is only so good, and you're not going to truly be able to understand the problem unless you can have that human interaction. And so that's one of the things that we try to facilitate. So far, we've been able to help 123 companies win about $150 million in government contracts and go on to raise $340 million in private venture capital. And and the reason why we bring up the venture capital when we talk about the accelerator program is because it validates our thesis about the technology. And so when the government is interested in this technology, and we also have private investors who are willing to vote with their dollars, that makes us feel really good about how we are allocating taxpayer dollars. So when we talk about some of the other innovation efforts that we have going on within what is now the SpaceWorks innovation portfolio, I just want to do a quick highlight of some of these efforts, just so everyone's aware. So we have the Catalyst Accelerator in Colorado Springs. It's a 12-week traditional small business accelerator. We have the Hyperspace Challenge in Albuquerque. It's a 1-week program focused solely on customer discovery. From time to time, we fund commercial accelerator programs through Techstars and Starburst. We have 3 SBIR, Small Business Innovation Research cycles a year that we look to fund companies through AFWorks. We have the International Space Pitch Day. We're starting a new effort called Space Prime. There's actually going to be at the Space Sector Market Conference. They're talking about that right now. So I'm sure there's going to be some more news later this week about that. And then we also have a Space Force Pitch Day event that we run. And when you look at all of these programs, and if you were to put them together on a timeline, you'd see that there actually is a natural progression between companies coming through an accelerator program, getting introduced to users, to going to applying for a SBIR Phase 1, SBIR Phase 2, eventually going on for a strategic financing or a tactical financing after that, and then trying to jump into a full-on Phase 3 contract. And so there really is a natural progression, and that's why we organize our innovation portfolio like that. So yeah, thank you, Brian, for having me.
Thank you. That's great to hear. And I've definitely got a question for you on sort of how that pipeline's been working and sort of how it relates to other non-space worlds. So before we get to that, I think Rick, you are up next with your sort of opening remarks. Great to see you again, and the floor is yours.
Thank you, Brian. Great event. Well, first of all, I do want to mention my little commercial here, Space Fund. We are a space venture capital company. Right now we have 17 companies in our portfolio. We're on our second fund. We're raising a $20 million fund. Anybody interested in investing in space, feel free to let me know. Yeah, we get that out of the way. Now I want to talk a little bit more generally. As you know, Brian, I like the big picture. I like to focus on really the larger scale of activities here. And you know, the concept, as Kerry was pointing out, was looking at the idea of satellite servicing, and then I think there was exploration, and then there was the third one, or human activities. For me, and the reason I started Space Fund, and those of you who know me understand this, was that we believe that we're sort of at that tipping point moment. We're about to hit it. In fact, I would call it, or somebody else called it, and I'll steal the term, we're on the verge of what you might call the SpaceX singularity, or the Starship singularity. And whether it's Starship, whether it's Jeff, whether it's our friends in New Zealand with Rocket Lab, the railroad tracks are coming. And what's really exciting to me about all of that is, while those kinds of activities, these sort of macro momentum shifts, or almost you know, the sort of cultural changes that we see when we're looking at a paradigm shift, are the accumulation of a lot of people's work then leading up to a small team and an individual grabbing it and going, now we're going to do this, and then the day after that everything is completely different. However, what usually happens right after that, or as a part of that, is the development of an entire, I hate to use the word ecosystem, but an entire ecosystem of suppliers, of suppliers of tools, infrastructure, secondary utilization methods, all of these different sorts of things. And those, in their own way, are all lots of little individuals and little teams. And I do want to congratulate Dalton and the Air Force, what they've been doing the last few years in terms of recognizing that and going down into that sort of very, very, very basic level and helping those entrepreneurs get kickstarted is amazing. I mean, it's transfer. If you had told me 10 years ago that I was going to see Air Force or Space Force as it is now, AFRL, that entire world focused at this level on creating innovation or enabling the innovation of these suppliers, I wouldn't have believed you. But what we have to do to get there now is to sort of standardize in advance, to think ahead of where we are going to be. So, I'm human settlement oriented. Maybe settlement is too far, too crazy. It's the S word for some people. So let's, and people talk about exploration, which infers government activities, and then we have the military activities. So why don't we just call it human activity? In space. And that's where I'm looking. I want to see human activities in space. So rather than getting into this phase now of robotic and complex systems to service other complex robotic systems in space, we need to start looking ahead to when people will be living and working and doing all kinds of activities, research, exploration, things like that in space, and standardize in advance to get there. And that means creating, on the one end, standard systems, which was mentioned earlier this morning. And I think that's one of the key things. We have to standard. You know what? I'm going to make the case that you can actually utilize Space Conference swag right now. This was given to me at a UAA space conference. One of the most fascinating and wonderful little devices that I've gotten at a conference. It's, of course, a universal plug for travel. Now, and
I have a couple of those myself because I do a lot of international travel and I really do work really well.
Exactly. And I want to thank our host for this one, the UAE Space Agency. But I don't want to have to use this in space. All right. These were all nationalistic projects leading to individually sized and voltages and amperage, all these things. We need to get rid of that. We need to standardize in space. We shouldn't need this or this, a universal this, or this, which is universal, which, by the way, manufacturers of each one of these are part of the ecosystem and they're making a ton of money. I've got this sitting here next to me, right? Okay, that should be a universal tool. But again, when I go to Europe or anywhere else, I have to use this to power this, right? This needs to be standardized. And yes, I'm a hardware guy. I think that's the key. Space Fund very rarely invests in rockets. There's too many of them. There's going to be a shakedown there. And we don't invest in satellite swarms. Again, probably too many of them. But what we are looking at is infrastructure and these kinds of activities. So at a high level, and I'll wrap up with this here, at a very high level, we need to focus on that. And I think CONFERS and groups like this should continue to push on this kind of thing. I have a thing. I have a book coming out called The Space Declaration, hopefully in the fall, maybe next year or the year after. I'm a writer, but in it, I'm going to talk about something I call right now the 7 R's, and this is critical and important that we adopt these ideas. And I've written a list because I'll always get it wrong. Number one, we need to eventually get to the point where things in space are either built and or propelled by native resources. They need to be reusable. They need to be recyclable, those parts of them that are not reusable. They need to be able to be repurposed. They need to be refuelable, which is being worked on right now. They need to be rebuildable, and those parts that overlap in some of those areas or may not fit any of those need to be resellable. One of the most important breakthroughs we will see in the next decade or so in space will be the development of a space junkyard, because that will mean that somebody has made an economic case for the recycling and reuse and repurposing of spacecraft or spacecraft components. And that's an exciting thing to me. You may not be into junkyards, but it's really something hugely important. And I think we need to work on international regimes that lead to standardization. Space is a place. It is not a program. It is not a national program. It is a place where we're all going to go. and we need to be able to work together. So the funding and support of companies that are providing those services, the creation of regulations that enable and, if necessary, force outliers into using these standard systems, the deprogramming of those people who work in space programs so that they understand that space isn't special. I want to be able to use my little 12-volt appliances on the space station, on Artemis, wherever the heck I go in space, right? I need to be able to plug my refueling adapter into whatever spacecraft I have in GEO or anywhere else. So these are the kinds of standards that we need to be focused on to enable this. And in the end of the day, just as if you look at automobiles, trucks, planes, trains, or ships, the economy that builds around them, that supports these very, very important elements of our infrastructure, is going to be, in many cases, larger than the economy created by those pieces of hardware themselves. There you go.
Yeah, great. Thank you, Rick. And actually, yesterday I opened it up. I gave a recap of some of the standards work CONFERS has been working on, and actually made that automobile analogy of sort of that whole supporting market. I'm going to come back to some of the standard stuff to get your thoughts on some of that. But first, I want to turn to Gordon for his opening remarks. And Gordon, you've got the floor is yours. Sorry.
Thank you very much, Brian. It's good to see you again. It's good to see DJ. I had the pleasure of mentoring 8 of his companies at the Catalyst Accelerator. Kerry, it's always been a pleasure working with Bryce. I had a lot of fun doing that. And Rick, you and I are always running into each other, and we're definitely on the same sheet of music. And you mentioned, Rick, you mentioned infrastructure. This is an infrastructure talk. I'm going to, a few slides on infrastructure, and it goes way beyond servicing. So servicing is, I consider, one market or one user of a much larger infrastructure that I call the space superhighway. So next slide, please. We want to go from this disposable mentality, as Rolf said earlier, and from a military point of view, a place where things are vulnerable, to a resilient, reusable. I put the 3R symbol up there. This is where we all want to go. Next slide. So I'm talking about creating a single in-space infrastructure for logistics. Everybody gets to use it. The commercial sector gets to use it. NASA, NOAA get to use it. The military, international partners get to use it. That's primarily privately funded and operated. So since the discussion here is making the case for the market, I'm going to have to make the case that there is a market for such an in-space infrastructure. It needs to be coordinated. People mentioning standards are right on. What should the government be doing? Well, they should be one of the customers for it. They might be able to provide seed funding like we did for COTS several years ago. And the R&D that government's doing, such as in robotics, such as in autonomy, is going to be vital in order to make this infrastructure really functional. But what do we get out of it? What do we get out of a big infrastructure that can bring things all the way to cislunar space, or bring things to GEO, or bring things to space stations? Well, from a military and a commercial point of view, we can get rid of this built-in obsolescence. We can start upgrading things earlier. This is part of the servicing. We can bring in nations that just want to get started in space. We can provide services, hosting services for their payloads. We're going to cut down on debris, because now we're trying to make use of everything we bring up and throw away less, and helping the entrepreneurs out. The example that I always use is Amazon. They didn't have to create a transportation infrastructure. It existed. And so they took that from the basement of Jeff Bezos's house to one of the world's 5 largest companies. Next slide. So this is some of the stuff that's going on now. In the upper left-hand corner, we have MEV, which is maintaining orbits for commercial spacecraft, increasing their value. Coming in 2024 is Northrop Grumman's mission robotic vehicle with the RSGS payload that will be able to provide additional services, again, to present-day assets. On the right-hand side, we see things that are coming along soon. We see the possibility of persistent platforms that can host payloads, small servicers that can just pick up the payloads and install them. Geo assets are moving in the serviceable direction. So for example, Lockheed Martin has announced that their 2,100 buses are going to be modified with refueling ports and ports for adding avionics on orbit. And then one of the high value things that really represents the core of the space superhighway is high delta V tug. To be able to take things from low Earth orbit, so reducing the energy requirements on launch vehicles and moving them out to GEO, to cislunar space, wherever, to L1, wherever cargoes are needed, reusably. So SpaceX has proved the benefit of reusing first stages. This is sort of like reusing second stages, or it reduces the demand on second stages so that we can move things around more efficiently. Next slide, please. Oh, and we're going to need to get a lot of fuel up there too. That's the other thing. This is a NASA slide coming out of the OSAM National Initiative. This is a more developed view of the space superhighway with hubs, wherever it makes sense to have hubs. Hubs allow you to store fuel, allow you to host modules, allow you to repair things. And as we know from terrestrial logistics systems, these hubs provide value. Right, next slide, please. No, other direction. There we go. Click 2 more times, please. The point of this slide is these are all the potential customers for an in-space logistics infrastructure. Life extension is a happening thing right now, but they're going to need more propellant. They're going to need more mission extension pods delivered. People are going to want to send new electronics to upgrade their satellites. Rick mentioned settlement, and there are going to be private space stations up there. They're going to need food. They're going to need towels. They're going to need athletic supplies. People are going to want to check out their hardware. NOAA wants to have serviceability so that when they have an instrument failure, they can do repair instead of waiting 15 years for a block upgrade. The habitats, once we get them on the moon, are going to need not only routinely delivered supplies, but perhaps emergency deliveries. Someone earlier mentioned, Carrie mentioned the in-space assembled observatories, another customer. So the bottom line is there's plenty of customers for an in-space logistics architecture, right? Some are in hand, some are coming, but each one of these is, a stovepipe. Each one of these would say to you, well, I can't develop a whole logistics infrastructure, but I sure could use one. So in the sense of making the case, this slide makes the case that if we move, and satellite servicing is just one of the potential users for this logistics infrastructure. Next slide. So the space superhighway is starting to get a look by policymakers. It really is, Rick said he didn't like using the word settlement. I don't like using the word transformational, but it's hard to explain this without looking at its transformational value. The industrial base gets helped because now we go from building whole satellites to building modules, so more people can play. There are opportunities for entrepreneurs and growth. Servicing really benefits from this, right? In so many ways, the lunar bases are going to need this, and really the logistics support for lunar bases hasn't been adequately addressed yet. And from the defense point of view, they'll be able to get technology at the speed of need instead of waiting for block upgrades, a decade later. So that's all I have. Thank you for the opportunity.
Great, thank you, Gordon. Appreciate that. So I have a whole lot of questions for you guys and I'm pulling some from the audience that have been dropping them here. And I know a couple of you have already been answering some of those questions offline. I want to start with Carrie. You talked about sort of the broader space market, and the question is, how much does the future satellite servicing market depend on the growth in other areas? Is this something where servicing you think can grow by itself, or do you think it's sort of closely coupled to how successful the LEO broadband market is, or how successful the future, of other space markets are?
That's a great question. And so I think it is coupled, right? We have to have things to service. If we're going to service them, they have to exist. But the satellite industry, remains very strong. And as Gordon and Rick mentioned, as we look out further, there's going to be kind of newer opportunities for servicing things going forward. But some of the things that we might want to look at outside of servicing on the satellite side is what are the trends there? As we see satellites getting more capable, maybe smaller software. What do software-defined payloads mean? That allows more flexibility on the satellite, but it also makes your satellite more valuable. So perhaps that increases the market for life extension, because now you really want to keep that asset going longer. But it's trade-offs, right? Because if I've got a flexible payload, perhaps that's less of a market for, people have talked about being able to swap components in and out for upgrading. So if it's software defined, maybe we don't need that, but keeping an eye on the trends in the things that you're going to service. So you need to know where are they going? What kind of propulsion are they using? What do their payloads look like? So you can be prepared. And that means that our servicers, and I kind of discussed this in terms of capabilities, is the idea that they are also more flexible as they can bring in and do more of the activities that you look at, right? So they cannot just inspect or grapple and move, they can reposition, they can swap it components, they have more capability. And I think that helps. The other piece to look at that we always have to watch for is what does the changing launch industry mean? And Rick started bringing this up. And in most cases, right, we say it's going to be a lot more capacity and it's going to be cheaper. So that means there's going to be a lot more stuff on orbit for us to service. That's one way the market could go, but there's some uncertainties. The other way could go is if launch is cheap enough, does it become a better business case for me not to service things, but just to throw them away and launch something else? So there's a lot of trade-offs as things change with the satellite and launch, which are at this point kind of the base customers for these services.
Yeah, absolutely. And I'm always reminded whenever I think about technology, right, there's always going to be unforeseen right knock-on implications of things and I talk to economists all the time. They're like, well, actually people ended up doing this instead of this other thing because of sort of the change in incentive. So it's always something to keep in mind. DJ, I want to turn to you. I want to pick up on something you mentioned. So you talk about sort of the space world, Air Force and Space Force are building out sort of this, I'll call it a pipeline to help bring in new commercial companies. How much did you guys study how that works in other sectors, not space, outside of space, like the IT world? Is that something you looked at? And what sort of difference did you see in terms of how the space world approaches startups and sort of building these companies versus how it's done elsewhere?
Yeah, so we had the advantage of a lot of lessons learned from the aircraft world. And mentorship from some Silicon Valley folks like Steve Blank to give us some input about how we should structure these programs. But when we think about this pipeline and the current state of how space programs have been designed and procured, it was ripe for disruption. And so putting people on a timeline that was in months rather than years really turned everything on its head. And so that's really where we started was, how can we get small, like measurable pieces of value from these R&D efforts from startups and work them through the program and graduate them to next levels. And we're still working on it. It's not a perfect process. And at the end of the day, we do have to remember that the SBIR program actually was not created to procure things. And I think a lot of folks don't realize that. SBIR is not designed to procure. It was originally set up to help grow the industrial base, and it is really beneficial for companies, I think, to have a plan of what they're going to do with those SBIR dollars or any other maybe OTA money for prototyping. What are they going to do with that? And I think, and what we try to vector most companies to do is to take that money and use it to get to the commercial market faster. Don't take the money and expect that you're going to have $100 million contract at the end of the year, because the government is still going to move slow. It's going to move slower than the commercial industry. But if you can use that non-dilutive capital to get to the commercial market faster, I think it's going to be better for everyone.
So following up on that, you sort of talked about how this is impacted with the industry side. How have you seen the Catalyst Accelerator, other initiatives impact the government side? Has there been a big change in how the government now views some of these startups, or some of the ability for the commercial sector to kind of respond faster and do things other than just sort of the typical defense contractor?
So I think engaging with industry has helped us look at, actually be accepting of new ideas, where originally, the military does have a culture of there is an established process, and at times we can be a little bit closed-minded. And I remember back in 2017, 2018 timeframe, you couldn't go into a colonel's office and ask them for money for in-orbit servicing project, or to say that you wanted to do this SBIR effort because you wanted to manufacture something in space, or talk about or even like talk about a moon base. People would not take you seriously, and they would laugh at you. But now you can have those really candid discussions and talk about on-orbit servicing and in-space manufacturing and cislunar exploration, and people take it very seriously, and which I think is a huge change in just the past couple of years.
Gordon, you want to chime in?
I agree with DJ in amplification of what he said. It's really gratifying to see the mind shift, and I think a lot of it had to do with the transition from Air Force to Space Force. Space Force is talking about space mobility and logistics as one of their 5 core competencies. And they haven't fully figured out what that means yet, but the fact that General Raymond said this is something we have to be able to do should be very encouraging for all of us. There are challenges to the government from some of this increasing commercialization. And let me mention, 2 of them from my own program when I was working on RSGS. Shortly after I retired, the government's partner, Maxar Technologies, had to drop out because there had been this downturn in the geo market. They ran out of capital and that sort of thing. It took the government 1 year, right, to pick a new partner, because they had to go through the processes. They had to have a proposal. They had to have an evaluation. They had to have a negotiation, that sort of thing. Can you imagine, Microsoft losing a partner and taking a year to pick a new one? I mean, that's absurd. So that shows why, and there was a question in the Q&A about why commercial. Well, that's certainly one reason. It's the agility, it's the ability to make decisions quickly. The government has to get used to the fact, if we're going to go with commercial, that market conditions change, and they're going to lose some of the control that they have with, say, a FAR-based contract, where every change requires a change request, and that's negotiated and price goes up and all that sort of thing. So there are challenges to doing this, and I think the Space Force is tackling those. It's learning how to do this. RSGS is a good lesson in what can happen and what market forces can make you do. But at the end of the day, there's so much more capital out there in the private sector than there is in government budgets. That's what's going to make this work. Right?
Mm-hmm. And I think that is really a change that's happened in the space world, right? We're used to that larger bulk of capital being there, and things like automotive world and things like IT world. But up until very recently, the vast majority of capital and contracts were coming from governments in space. And I think that is one of the big things that changed. So Gordon, following up on that, and I'll ask you to kind of maybe comment, and anybody else wants to chime in. So that gets to sort of what is the government's role in all of this? We talked about sort of, we touched on a little bit with DJ talking about sort of this initial pipeline to kind of support early stage development. We, Carrie talked a little bit about sort of the contract side, whether it's human spaceflight and other things. What sort of things should the government be doing, either more of what they're doing now or differently, to support and help, foster this industry?
So I like to look at NASA's COTS program, Commercial Orbital Transportation Services, as a great example to answer your question. The government provided $500 million that was split between two companies, and 2 new launch vehicles resulted, right? Now, there was less, so there was seed, that was the seed funding part. And then they said, hey, we're going to be one of your customers, right? They couldn't promise contracts because the government can only commit to the current year's appropriation. But they alluded to the fact that we're going to need resupply of the station. We're going to want to send humans from American soil back there. And so the government essentially became an advanced contractor. The third thing that government needs to keep doing, because of the expertise at our labs, the Naval Research Lab, the Air Force Research Lab, is the R&D that helps make all this work better. So I think with those 3 contributions, some seed funding, some indication of interest, and in being a customer, and continuing the great R&D that's going on, those are reasonable government roles, and not that costly either compared to trying to field this on our own.
Yeah, $500 million of investment to get 2 new launch vehicles. That's pretty small in terms of the government. So
compared to the Space Launch System.
Right. So Carrie, you want to jump in?
Yeah, I was going to mostly agree completely with Gordon and all those, and think about, ways in particular the government can be a customer. So the idea that, I mentioned that you see some of the big geosatellite operators tend to be a little more risk averse, and that's where the government can kind of step in as a customer and early adopter. The government's got a lot of new systems coming online in the next few years. They could demonstrate, become a customer for some life extension for some other servicing or debris removal, to really be able to allow other potential customers to see this being done and reduce the uncertainty and risk. Gordon, jump in.
I would add to that, though, the mission extension vehicles, which are opening everybody's eyes to the possibilities, were developed without a penny of government funding. Yeah. And they're operating on commercial satellites, which is very encouraging, right? If there's money to be made, as Steve Spangler, the CEO of Intelsat, says, if a satellite is making money, why would I want to throw it away? Mm-hmm. Right now, the government needs to adopt that same mentality. If the satellite can save taxpayer money, why wouldn't I want to do this?
Mm-hmm. Mm-hmm. Yeah. So go ahead, Carrie. That's
one of the most extraordinary things in this market, is the amount of commercial interest, the sheer number of commercial companies at different levels of the supply chain that are interested in this. And that's kind of thing that you see DJ and his group at different supplier levels supporting to kind of build up the technology and the capabilities, but also just the investment. I'm sure Rick can speak to this better than I can. Large amounts of investment. I mean, I think that, in space overall, we're looking at billions of dollars of investment in 2020, and a lot in these areas as well.
So Rick, I don't know if you want to chime in here at all, and also if you could move a little bit closer to your mic, or you were a little soft in the first round of things, but please, Rick. Ooh.
Yeah, and look, the investment is flowing in, as I kind of touched on in my presentation. We have to spin people away a little bit from rockets and constellations, and get them into the more boring stuff. There's the old analogy. I know you guys have all heard it. It wasn't the gold miners that made the money. It was the guy who sold them Levi's. There's also the people that sold the pickaxes manage the transportation systems and all the other stuff around them. And we have to get people to understand that that's where the real money is going to come from when it comes in terms of investors. There was also this conversation. We spent many years in Space Frontier Foundation, a little plug for that org, back in the 90s, putting together what was the white papers that we believe led to COTS. And the idea, again, was to create a competitive market that we believe would drive costs down. And we're shifting now into that orientation. Part of the battle that we have seen until now has been this battle that's gone on between the aerospace industrial complex, which is a programmatic orientation, keep the costs high, build in your obsolescence so you get a new program, keep the money flowing to political. And what's happening is, as you see these more frontier-oriented companies come along, whose goal it is to get as many people out there as possible, they actually focus on bringing the cost down, multiple suppliers, et cetera, as far as a community. And so, we have to constantly look at the goal and not confuse the goal for the doctrine. So the goal in a battle might be to win the war. The doctrine is we're all going to wear red and we're going to march in a straight line and we're all going to wait for the other side and we're all going to politely and then we're going to attack each other, right? That's doctrine. And we have a tendency to sort of do this in fits and starts. Like somebody will come along with a lot of vision and say, okay, here's the goal. And then the institutions will adopt that goal. And then that goal then becomes doctrine. And now we have to go through the doctrine to achieve the goal. And you lose the fact that the goal was, hey, I just need some people carried to and from a space station, right? As cheaply and safely as possible. That's it. And so we have to constantly churn that up. And I think one of the things that's happened with the rise of Space Force, et cetera, outside of the actual physical entity of Space Force, is that it has shifted this idea of doctrine in space into the idea to creating a new opening, a bunch of new minds to come in and start focusing on the goals and the goals of how we are going to develop these kinds of activities in space. And that creates an opening for creativity. My fear, and we always have to be on guard on this, is that some of these things will now become the next doctrines. So we have to keep pushing, churning, and that's what real commercial activities are about. We started with COTS. We started with this idea. It was going to be pay for service, et cetera. And of course, now we have one company that's doing pay for service, and then we have another company that's doing pay for service plus whatever my lobbyists were able to convince you to add to providing the same service. So, those messy human beings screw up all of these theories. But I think commercial activities and competitiveness, when we can keep them at the forefront, will help us just keep innovating.
So, Rick, I also want to follow up. You mentioned in your opening remarks of the value of standardization. That's really something that's very close to our hearts here at CONFERS, because that's why we were created originally. And Pam talked about that yesterday in her opening keynote about the importance of standards. One of the challenges we've come across in trying to develop those standards, we now have 3 that are in work as a result of what CONFERS has been doing, is a chicken and egg problem with practice. So some of the concerns we get are, how do we know what the standard should be if we haven't actually done any of this before and haven't actually done the practice before? And there's also a related concern that by standardizing, you're going to sort of cut off some of the innovation, right? So I don't know if you have any thoughts on how to address that, and I'll let you respond. Anybody else wants to jump in as well, more than happy to.
If you're going to be focusing on standards, look, standards enable basic cross-utilization and expansion of markets because of understandability and interoperability. And so that's critical. If you're going to be developing standard, one thing top of mind, don't let the politicians get involved in setting the standards. They have nothing to do with it. Keep them out, right? Keep them out. Focus on the consumers, end consumers. Look what's happening in Europe right now. Apple is very upset because Europe has just decided that all mobile phones have to have the same plugs. Now, in my world,
As a consumer, that's great, by the way. I would love that, right?
yeah, in my world, it would be the Apple plug, but I get it. I get it. So now that, by the way, that standardization forces a shift. So now you can have mag, and wireless, and then you jump right over and you go to another level of innovation. But again, I think that it is always going to be a competition. There's always going to be that push and pull. But look, coffee mug, standard, right? And if it works, and it comes into play, and you can at least have a mechanism so that you can update if necessary in your system of standardization, that's great. But some things just work, and there's really not much better of a coffee mug than a coffee mug.
And yet there's a lot of room for innovation. What goes on the outside of the coffee mug, right? And that sort of thing. Gordon?
Exactly.
Well,
they're
It's a
not-
platform for innovation. I'm sorry.
Yeah, Gordon, go ahead.
The coffee mug size is not standard, right? They're a little bit bigger, a little bit smaller, and that sort of thing. Handles have different shapes. This is why early in the development of space robotics at DARPA, when we started the SUMO program, we had already concluded to not try to force standardization on the industry, but to use robot arms, which are very flexible. They can deal with things of varying sizes and put varying tools on them in order to do useful things without requiring standards. Because we knew that the space industry is conservative, it's hard to get them to adapt new things and that sort of thing. So we said, we'll deal with what's there. We'll use robotics. There you go. You've got the capacity to deal with both metric and English units with that adjustable wrench, right? Same thing. So I do believe that standards are important at some level. I also think that we shouldn't feel paralyzed because we don't have standards yet, because there's so many good things that we can do without them. And by the way, I would point out that there's one robot grappling mechanism that's TRL-9. On the Orbital Express mission in 2007, there were some modules that were transferred from Astro to NextSat. There was a little ball and stick on the top, and there was a tool on the end of MDA's robot arm that could pick that thing up. So that fixture and that tool are proven, and if you want to move things around in space, it's already a done deal, right? And by the way, the receptacles and the connectors at the bottom of those are also TRL-9, right? So back in 2007, we had already done what needs to be done today in space.
Mm-hmm. So I want to pick up one more thing, and this is for you, Carrie. There was a question answer that was answered earlier about sort of ground systems. I want to pick it up to get your thought on it, because it's come up with some of the CONFERS things. All these space activities, at least for now, require some sort of ground infrastructure for communications, for command and control, for sending things back. Carrie, how do you see the existing ground system sector, and whether it's big enough to support some of the things we're talking about with servicing? Have you seen anything in your research on any challenges there, or any need for that to grow, or any complications? That was a question that came up earlier.
That's a great question. I think that we're seeing changes in ground as you're starting to see ground as a service. And this is part of the reason this is starting to come up, as we're seeing the kind of explosion in LEO and just the new ideas, right? The looking at platforms, the different kinds of activities that would now be taking place. So we're seeing more and more companies now looking at operating that ground as a service as a way to position themselves within these new markets. And I think that's kind of the biggest trend that we're seeing right now.
Great. All right. Well, thank you all. We're out of time for this session. I need to go ahead and wrap up. Unfortunately, I have a live audience here to give you guys a big round of applause, but I really enjoyed the discussion. Thank you very much for your contributions. And I will hand it now back over to Harley, who's going to be introducing the next section.
We've got, I think it's kind of appropriate that the last presentation and the Q&A concentrated on, to a large degree, on robotic systems in space, appropriate for the last topic. So this moves quite smoothly into the next session. And for you in the audience, what we're going to do is something that you all are getting very comfortable with. The next several minutes, 10 or 15 minutes, is going to be pre-recorded. sit back and enjoy. But the presenter, Gerhard Grunwald, will join us live. So once again, sit back, enjoy the pre-recorded presentation, and put your questions into the Q&A, because that's from where I will draw the questions for Gerhard. And many of you know him. Gerhard is the coordinator for on-orbit servicing at DLR and its robotics operation. And I think we're ready. You guys start getting ready to put your questions in. And so let's roll Gerhard's presentation.
Hello, everybody. My name is Gerhard Grunwald, and I'm working on service robotics for more than 30 years. Of these, 10 years in space robotics. In my video, I want to highlight robot capabilities needed for performing dexterous service robot operations like grasping, handling, assembly, or generally speaking, task-directed, safe physical interaction with the environment. From the functional perspective, there is no real difference between services on Earth or in space. But when you compare the service capabilities of today's space robot arms and on-ground service robots for industrial, domestic, or professional service, you will see an incredible difference in the performance. DLR has a lot of experience in building and using lightweight service robotics. We started already in the early 90s when developing a lightweight robot arm for training German astronauts to operate a robot in Space Lab. This lightweight robot technology in the version of 3 is a change of paradigm in robotics, from large, rigid, and position-controlled to lightweight, compliant, and adaptable. This technology was transferred to KUKA, one of the largest robot manufacturers worldwide. The commercial product is named IVA. You can see it on the right. In parallel, we brought this technology to the outside of the ISS. Over 5 years, we could verify that our joint and electronics technology is working without any performance degradations. This verification was implemented using the new space approach, but I cannot remember whether this name already existed at that time. In the past, we were participating in some on-orbit servicing projects. The focus of the German orbital servicing mission, DEOS, was on the on-orbit verification of key robotics hard and software elements for advanced space maintenance and servicing systems. The most difficult but most interesting task for the robot was grasping a tumbling, non-cooperative satellite. In the younger time, we were participating in some European space project with different industrial partners. Our task was mainly the implementation of on-orbit servicing tasks, and this was working fine. Here in this video, you see the scenario of assembly of a space telescope, which is known since many years for every space roboticist. The challenge here is to handle 3 connectors in parallel. And this type of assembly is only possible using impedance-controlled robot arms. The frankly wiggling is a human-like strategy putting things together. The robot arm used in the terrestrial demonstration is the previous mentioned KUKA IVA manipulator designed for automation tasks. This is what we call true service robot assembly. It's not just pick and place. True, because it's a state-of-the-art technology which commercially applied in automation industry. What if we have this robot performance in space? This dexterity or technology would be a game changer in space robotics, as it was in the terrestrial robotics 20 years ago. CESAR is a space service robot. Since the beginnings of the DIOS mission design, we are working on the implementation of this space robot arm. Here you can see some CESAR requirements. One is that in each joint, the robot will have position sensors. The current length here for the DIOS mission was 3 meters with a weight of 60 kilogram. And the design is such that it can survive 10 years in space, but depending on the thickness of the aluminum, also longer. The CESAR design requirements are driven by the use cases in LEO, GEO, deep space, as well as on Moon or on Mars. We were looking for production and qualification that is efficient and accurate, and so that we can ensure commercial success and confidence in operation. CESAR is adaptable to various carriers and different types of satellite or spacecraft. And due to its modular design, different configurations or kinematics are possible. The current status of CESAR is that we have implemented an engineering arm, and you can see that the arm is already in action. What you see is an implementation using components off the shelf. But the design itself is final, and we can exchange each of the COTS part by a space qualified one. Here, the playing around or throwing around the CESAR arm is to demonstrate the sensitivity of the robot arm, because the robot arm is measuring the forces applied and it is reacting by moving in the opposite direction. As in each of the joints are this type of sensors, we have the sensitivity over the entire arm structure. Here, this method is an implementation of a spring, so that the robot is always coming back to the original position. And also the accuracy of the robot arm is very high. As you can see here, the robot is grasping with a gripper dummy a tube, and you can see on the video in the left upper corner that the robot is moving very, very smooth. And I have to say that this video is from last year, about 6 or 8 weeks after we have put it on the ceiling. The modularity of the robot arm can be seen on the right, upper right image, and also a scenario where to apply it. So this is the presentation of our CESAR arm, and if you have some questions, please let me know. I will answer it in live. Thank you.
Okay, great, Garrett. That was terrific. And again, a great follow-up to the previous set of questions. We are running just a bit late. Does anybody have a real, I'm looking on the Q&A, there is not really a quick question for you, Gerhard, but let me note, folks, that check out the chat, because Mark, once again, has offered an opportunity for Q&A following Gerhard's presentation. Check out his link. Please do it. Gerhard, that was terrific. So we apologize that we're so tight for time. And we should have Ian coming on now to bring us into the break, give us a heads up for the breakout sessions to follow. If Ian wants to do that at the end of the break, that's totally fine. So let's go on with let's begin the break.
So this is Ian Christensen. We do have one question now. So Gerhard, if you
there he is.
Yeah. So the question is, do you have any plans for flying this arm at this time?
Yes, we have some plannings within the European context. There are, or the EC European community context, they are planning an IOD within the next time frame of 4 years, and we want to apply with it to bring in our robot arm. We are in a consortium with it. We just the provider of the robot arm. We are also looking for other applications, for examples on the Bartolomeo platform on the ISS, to demonstrate the performance of robotics. What I see with the current robotic designs for space is that it's more focused on the performance of, let's say, 15, 20 years ago than compared to the state of the art, which is on the Earth now. And this is also what I heard today, or what one point of today is, we should bring the technology from Earth to space. To my understanding, it's not anymore the way around that the new technologies are developed for space and then are brought back to Earth.